In the last video, we looked at linear equations in 2 variables. This time, we're going to look at 3 variables, and this is actually talking about 3D lines. So you don't just have your X and Y plane, you have your Z plane, which would be coming out of the table. So you've got a 3D picture in here. Now, to check to see if something is a solution, we do what we always would do. We plug it in. So it's always going to be X, Y, and Z because they go in alphabetical order. So I'm going to plug in 1 for X, and then 2 for Y, and then -2 for Z. And we're trying to see if that equals 9. So 1 plus 4 plus 6 does not equal 9. Do I need to check any other ones? Remember, it must work for all 3. So this is a no. Now, when we're working with, there's a typo on here. This is supposed to be a -2y. Okay, so fix that. When we're working with systems of equations, elimination method is really the best one. But to do that, we have to take 2 different pairs of the equations. We have to pair them up. So we don't do elimination with all 3 at the same time. We do them in pairs. So we're going to have pair 1 and pair 2. Now I need to start thinking, so I'm going to label these 1, 2, and 3. Which variable do I want to eliminate? Vote off the island. And I noticed that I have a -4z and a +2z. These might be the easiest ones to work with. So I'm going to eliminate z. So I need to eliminate z from both pairs of equations. So I'm going to take equation 1 and equation 2, but I will need to multiply equation 2 by 2 to get a +4z. So equation 1 is going to come just like it is. And I'm going to do 2 times equation 2. Let's add those together. Nice, z is gone. Pair 2. I need to combine 2 different pairs of equations. So I still want to get rid of z. I think I'm going to use 2 and 3. I think I want to do 3 times equation 2 and -2 times equation 3. Let's see what happens. So I'm going to take 2 times equation 2, 3 times equation 2. So 3 times 3x, that's 9x, 9y, 6z equals -9. Then -2 times equation 3. So -2 times -2x, then -2 times 5y, then -2 times 3z, and then -2 times 3. I'm going to add down. Now I've got 2 equations and only 2 variables. I think I'm going to use elimination again. This one's okay, but this other one, if I multiply by 4, I'd have 4y and -4y. So times 4. 4 times 13 is 52. And I have a -4y and a -60. When I add those together, I get a 63x. These cancel. So x equals -1. Well, that's awesome. Now I can plug that in somewhere to find y. How about let's use that second equation there. I know what x is, so I can plug x anywhere I want. So I get -13 minus 1y equals -15. Negative 1y equals negative 2. So y equals 2. We're almost there. We need to find z. So let's see. We need to find z. So I'm going to have to go back up to one of these equations. Doesn't matter. I'll just pick equation number 1. So 5x minus 2y minus 4z equals 3. So I've got negative 5 minus 4 minus 4z equals 3. That's negative 9. So I'm going to add 9 over here and get 12. So z is negative 3. So my solution is always going to be a point, and in this case it's x, y, and z. Now the next example, you'll notice that on this first one, it already is missing something. It is actually already missing a y. So I think I'm going to combine 2 and 3 and get rid of y. So I'm going to combine 2 and 3 and get rid of y. So I think I'm going to do negative 2. So let me label them. Negative 2 times equation 2. And then leave equation 3 just like it was. Add. So now I've got this new equation, and I still have equation 1. Oh, I see something. Look at what's going to happen. I can just add right from there. So z equals negative 5. Oh, positive 5, sorry. Let's see. Well, no, equation 1 said x plus z equals 8. So x plus 5 equals 8. X is 3. Now I need to find z, so I'm going to pick equation 2 and plug in 3 for x and 5 for z, and that's a 17. Sorry, my pen kind of bled there. That's supposed to be a 17. So that's a 10. So 3 plus y plus 10 equals 17. So y equals 4. Now, example 4, I'm going to have another video on. I just wanted to get one up for while I was gone on Friday, but I'll have another video on problem number 4.